Hello everyone, I'm Rilo, and in this module, we'll be discussing norm and distance in n space. Let's dive in. By the end of this course, students are expected to have these abilities. The first one is demonstrate vector operations, and the second one is implement the concept of vector norm and distance in Cartesian coordinates. Now, we talk about norm definition. The norm or length of a vector v is denoted by like this. Figure A suggests that the norm of a vector v follows the theorem of Pythagoras, where the norm of v equals to the square root of v1 squared plus v2 squared. And similarly, a vector v in 3 space also has a norm. The norm of v equals to the square root of v1 squared plus v2 squared plus v3 squared. And if we have the vector v in n space or in Rn, then the norm of v is defined by the norm of v equals to the square root of v1 squared plus v2 squared plus and so on until plus vn squared. For example, if we have v equals to factor minus 3 to 1, then the norm of v we can calculate as the square root of minus 3 squared plus 2 squared plus 1 squared. Minus 3 squared is 9, plus 2 squared is 4, plus 1 squared is 1. So 9 plus 4 plus 1 is equal to square root of 14. So the norm of v equals to the square root of 14. We can also measure the distance between two vectors. If u and v are points in Rn, then the distance between u and v is defined as duv equals to the norm of u minus v, and we can calculate it as the square root of u1 minus v1 squared plus u2 minus v2 squared plus blah 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 until plus un min vn squared. For example, if we have the distance between u is 1, 3, minus 2, 7, and v equals to 0, 7, 2, 2 is duv equals to the square root of, we subtract all the corresponding components. So we have 1 minus 0 squared plus 3 minus 7 squared plus minus 2 squared plus 7 minus 2 squared. So we have the result is the square root of 58. The conclusion of the module is, the first one is, if v is a vector in Rn, then the norm of v, or the length or magnitude of v, is divided by the norm of v equals to the square root of v1 squared plus v2 squared plus blah 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 until plus vn squared. And if u and v are points in Rn, then the distance between u and v is defined as duv equals to the norm of u minus v, or the square root of u1 minus v1 squared plus u2 min v2 squared plus and so on until un minus vn squared. Alright everyone, that wraps up our discussion on norm and distance in n space. Thank you and see you in the next video.